Hey, what's up everyone? Welcome to NCX Math. And previously in our video we discussed on some basic topics from points rate topology. So where we discussed on an open ball, an interior point, exterior point and boundary point of any given set. And today in this video we're going to discuss on some important topics from points rate topology. So here in this session we'll discuss on open set, closed set, and then some of their examples. So first let's start with the open set. And open set is defined as a set A which is a subset of R, that is real number, is said to be an open set in R if every point of A is its interior point. So here in this definition, open set is defined in terms of interior point, which we have already discussed. You can find this video in the playlist of our channel. So a set will be an open set if all its points are its interior point. And also, without using this term interior point, we can define open set in this way as well. A set A, which is a subset of real number, is said to be an open set in R if for all x belongs to A there exists R, which is a radius for an open ball, R greater than 0, such that ball with center x and radius R lies entirely within the set. So this means the set A will be open if for any element from this set A we can always find an open ball which entirely lies in this set A. So if this is true for all elements of set A, then we can say that this set A is an open set. So we can make it more clear from its example. So here we have a simple example for this, that every open interval is an open set. So this can make us more clear about open set. So open interval, let's say this is an open interval which ranges from let's say -2 to let's say 9. So this is an open interval -2 to 9. So which includes all the points between these numbers -2 and 9, but excludes these 2 points, these boundary points -2 and 9. These are not included in the open interval. So if this set is A, and if we take an element, let's say 0, which lies in this set, it's very clear. So for this point 0 we can always find an open interval. Let's say with radius, we can choose the least radius we like, let's say radius 1. Okay, so this ball with center 0 and radius 1 means this 0 plus 1 and 0 minus 1. So 0 plus 1 is 1 and 0 minus 1 is this -1. So this is the open ball with center 0 and radius 1. And it is very clear that this ball with center 0 and radius 1, which ranges from -1 to 1, and this open ball entirely lies within this set A. So we can say that this point 0 is an interior point of this set A. Likewise, we can find that all the points inside this set is its interior point. So let's suppose another point which is very close to this boundary point, let's say -1.5. Okay, so this -1.5 which is very close to this left end point. So for this we can find a radius. Let's say we can choose a radius of length, let's say 0.3. okay, 0.3. So this open ball with center at -1.5 and radius 0.3. okay, so this is, so -1.5 plus 0.3 will be, this will be -1.2. yeah, this will be -1.2, and -1.5 minus 0.3, and this will be -1.8. okay, so we can see that this ball with center at -1.5 and radius 0.3. so this is the open ball, and here in this case also this open ball entirely lies within the set A. So this shows that this point -1.5 is also an interior point of this set A. So there would be a problem only if we select this boundary point -2 or 9, but these are not the element of this set A, so there won't be such problem that the ball won't lie inside the set. So we can say that for any point of this set A we can always find an open ball, and that open ball entirely lies within the set A. Hence all the points of set A are its interior points. So we can say that the set A, which is an open interval, is an open set. So I hope this gives you a clear idea about the open set, and if you still have some confusion you can comment down below. And next we are going to discuss on closed set. And closed set is defined as a set A, which is a subset of real number, is said to be a closed set in R if its complement is open in R. Okay, so here closed set is defined in terms of open set, that set A is enclosed, the set A will be closed in R if its complement, that is R minus A, is open in R. So for a set to be closed, its complement must be open. That's the idea. And here we have a simple example that the closed interval is a closed set. So every closed interval is a closed set. Suppose we have a closed interval, let's say a closed interval which ranges from 1 to, let's say, 7. Okay, so this is a closed set, or we can say that it is not open because all of its points are not its interior points. Because so for all the points including 1 and 7, we can always find an open ball which lies inside this set. But since this is a closed set, 1 and 7, these boundary points are also its element, but for these boundary points we cannot find an open interval which completely lies inside this closed interval. So here you can see that I have made an open ball with center 1 and radius 0.5. okay, 0.5. so this will be 1 plus 0.5, so this will be 1.5, and 1 minus 0.5, this will be 0.5. So this open ball ranges from 0.5 to 1.5, and this whole open ball does not entirely lie inside this closed interval 1, 7, because half of the portion is already outside. So the same goes for this boundary point 7 as well. So we can say that closed interval is a closed set because it is not open. And also we can say that this closed interval a comma b is closed, since suppose here we have closed interval ab, so its complement, so this is set a which ranges from a to b, and its complement is clearly from minus infinity to a, and here in this side from b to infinity. So union of these two intervals, these two open intervals, is its complement. So this is the complement set of a, and we can see that this complement of this closed interval a comma b is minus infinity to a union b to infinity, both being open interval. And union of open interval or union of open set is also an open set. We'll prove this fact in our next video. Complement of this closed interval is open set. So we can say that this closed interval is a closed set. So using these two different logics, we can say that closed interval is a closed set. So guys, I hope this gives you a clear idea about closed set, and if you still have confusion, please comment down below. And if you find this video useful, don't forget to like this video, subscribe our channel and turn on notification for more higher mathematics related videos. Thanks for watching. Have a nice time.